Okay, you guys, 8.1 part 1, okay, has a couple of review topics, and a lot of this should look familiar, but we're just talking about basic right triangle trigonometry, and that should ring a bell of sine, cosine, tangent. But first thing we're going to talk about is just a reminder from last time is the Pythagorean theorem, which helps us solve for sides. When solving for a side, okay, to use the Pythagorean theorem, we need to have two of the sides. Okay, that's a big thing if we remember that. And if we remember too that our angles are capital letters and our sides are the lowercase letters that are across from it. So Pythagorean theorem is little a squared plus little b squared equals little c squared. So no matter what two sides or three sides you have, two sides, you can solve for the third side using the Pythagorean theorem. So real quick, if we were to do this example right here, it says to solve for this little b, so that means that this would be angle B, and this would be angle A, okay? This would be little a, and this would be little c. So if I go a squared plus b squared equals c squared, a squared is 20 squared, b squared we don't know, and c squared is 30 squared. And so we get our calculator out, okay? We do 20 squared, and we get 400. And we do 30 squared, and we get 900. And we got to solve for b squared, so I minus the 400 on both sides to get the b alone. Okay, and a lot of us would reach for our calculator right now, but we don't want decimals at the moment, so we're going to take the square root of both sides, and we get b equals the square root of 500. And we're going to simplify that root by going what times what is 500, and I think of 5 and 100, and 100 is 10 times 10, and I've got buddies, and then the 5 stays inside, so I'm going to say b equals 10 square roots of 5. That's the length of it. You could type it in your calculator, okay, 10 and then square roots of 5, and that's about 22.4. Okay, so just a reference, but this radical is a better answer because it's exact and not rounded. Okay, that's review from last time. Hopefully that rings a bell. This should also be review. Okay, but what you need to remember is C is always the right angle. Okay, and then it doesn't really matter A and B. Okay, that's how we would label this triangle, but for SOHCAHTOA, for sine, cosine, and tangent, we have this idea of theta, okay? So if you see this sine theta, okay, that just means that's the angle we're talking about. So if I put theta right here, I have to label the sides of the triangle based off of that theta. And we have an opposite, adjacent, and hypotenuse. So this side is the opposite. This side is adjacent. And C will always be your hypotenuse. Okay, so if we remember sine of theta, sine equals O over H. And it would be written sine of theta equals opposite over hypotenuse. Okay, so we would take this, on this one, it would be little a over C. Okay, for cosine, so cosine is a over h, and you write it as cos or cos, some people say, but say cosine. Cosine of the angle theta equals adjacent side over hypotenuse, okay? And on this one, it would be little b over c, okay? And then tangent is the TOA, which is O over A, or tangent of theta equals O over A, okay? So we're going to use those main three things. We're only going to focus on 3. There's actually 6, but we're going to just focus on the 3. Okay, and we are going to find the trig ratios for the following triangles. So the first thing I do when I get to an equation like this is identify where theta is. So there's the angle it's talking about. Then I'm going to label the sides. The one across from it is the opposite. And then the hypotenuse is always the long one, okay? And adjacent is the one next to it. And a lot of people have a hard time with adjacent and hypotenuse, so be careful, okay? So then I'm going to go through this. And sine of theta, okay, sine is O over H. So this equals 8 over 17 because the O is 8 and the H is 17. Cosine is A over H, and we get 15 over 17. And tangent is O over A, which is 8 over 15, okay? And those are your answers. The only time it changes is if you can reduce your fractions, okay? But on these, I know I can't reduce because they don't have anything in common. But if you can reduce your fractions, reduce them, okay? Here's a second type, and this takes a little bit of thinking. Is this one says, if the sine of theta is 5 over 13, find the rest of them. So we know that this is O over H. So I'm going to draw a triangle. I'm going to draw a triangle, and I'm going to have this theta. I'm going to put theta right here. If that's the case, then the opposite would be 5, and the hypotenuse would be 13. So the only one, I need to find the adjacent, so I'm going to have to use the Pythagorean theorem. So I'm going to go 5 squared plus b squared equals 13 squared. And I get 25 plus b squared equals 169. Subtract the 25, and I get b squared equals 144. Square root it, and I get b equals 12 because 144 is 12 times 12. Okay, that's a little extra that kind of combines the things we've done with this, okay? But I'm going to answer the questions now. Sine of theta, they already gave to us. So we know that the sine of theta is O over H, which is 5 over 13. Cosine is A over H, which is 12 over 13. And remember, opposite, adjacent, hypotenuse, okay? And tangent is O over A, which is 5 over 12, okay? So if it ever asks you for the ratio, remember that you're finding the fraction, okay? Sometimes they're going to be asked to solve for a side, okay? And if you're asked to solve for a side, you're going to write a sentence, but you have to know which sentence to write. And I know that sounds silly, but we're going to write a math sentence. So first thing I'm going to do is I'm going to identify my theta, and I'm going to label my sides: opposite, adjacent, hypotenuse, okay? The sentence I'm going to choose is the one that uses the adjacent and the hypotenuse because that's the information that I have, okay? So A and H is cosine. So I would say cosine of theta equals A over H. And I'm going to fill in what I know. I know theta. Cosine of 60 equals 5 over x. And then I'm going to solve for x. And the way I solve for x is, if your x is on the bottom, okay, we can think of this, if this is true, then we can flip both of these. So we have 1 over the cosine of 60 equals x over 5. And then I can multiply both sides by 5 to get x by itself. And I get x equals 5 divided by the cosine of 60. And I'm going to grab my calculator, okay? I'm going to grab my calculator, okay? And I'm going to first make sure that my calculator is in degrees. So I'm going to go to the mode button and see this third one down where it says radian. I need to move it over to degrees. Well, I'm going to push enter. Okay. Then I go 5 divided by the cosine of 60. And I'm going to close my parentheses. And I push enter. And I get x equals 10, which means that h equals 10. Okay? So on this next one, I'm going to do this last example. Feel free to pause, ask questions, whatever you need to do. Okay? But make sure that you're understanding this. Okay? So take a moment, try to understand that problem if you're not seeing it. A lot of this should be reviewed though. You did this in secondary math too. But if it's not reviewed, that's okay. Just keep trekking forward. So first thing I'm going to do is I'm going to identify my theta. My theta is B. So this would be the opposite side, and this is the hypotenuse, and this is adjacent. So the sides I have are opposite and hypotenuse. So I'm going to write my sentence. The one that uses that is the sine of theta equals O over H. And I'm going to fill in what I know. Sine of 54.7 equals X over 7. Okay, and then I just need to get the X by itself. So I'm going to multiply by 7 to get the 7 off the bottom. I get X equals 7 sine of 54.7. And I grab my calculator and I go 7 sine of 54.7. And I get 5.71. So that's going to be X equals 5.7. Okay. I'm reading instructions, rounded to the nearest tenth, made it 5.7. Okay. Submit these, have them completely filled out. We'll continue with the rest of it next time for next class. So get started on your homework assignment.